This is Christian Avalos with the Screencast assignment number 3, where we were asked to find the velocity of a bouncing ball right after its first bounce off of the stage floor. Here I drew a diagram, which is basically what the video showed. Um, you can see that the ball was bounced at some distance before the first post, and then uh, the projectile went uh, across the post and then back down. I listed all the knowns. I calculated the initial frame, which was when the ball was first in contact here, which was 4, and then once it was in contact at the end, which was 43, and the total of that, the difference was 39 frames. And then the rate, which they gave us, was 30 frames per second. The distance between the posts was 2.7 meters. The acceleration in the x direction was 0, and the acceleration in the y direction was negative 9.8 meters per second squared. Um, our unknowns is the initial velocity after the first bounce. We don't know the maximum height that the ball reaches, and we don't know that the total distance that the ball goes across the stage. So then I solved for time first by converting the frames and dividing that by the rate of frames that they gave us, and got that the total projectile of the ball was 1.3 seconds. Then I calculated the average velocity of the ball between the two posts, but I found that to not be too useful because that's only between the posts, and the ball still travels some distance before and after the post. But then I went on to using these formulas here. I isolated the x and y components to find the velocity in the x and y direction, and here I used this formula and then rearranged it for the initial velocity in the x direction and plugged in my values and got that the initial velocity in the x direction was 0 because the acceleration is 0 in the x direction. Then I found the y component and rearranged the formula again and solved for the initial velocity in the y direction. So we knew that the final velocity in the y direction was 0, and that the acceleration was negative 9.8 meters per second squared, which is constant, and that the total time was 1.3 seconds, and your total velocity in the y direction is 12.74 meters per second. And then I use some trigonometry to solve for um, the total velocity, and then because the x direction was 0, your initial velocity was 12.7 meters per second.